Welcome back. So at this point, we should be pretty familiar with working with parallel and perpendicular lines. In this video, we're going to be given two lines that pass through two given points, and we want to classify them as either parallel or perpendicular or neither. So let's look at a few examples. Let's say we have line 1, and this line passes through the points 1 and -2, and the point 7, 2. 7 and +2. Okay, and then we have a second line, line 2, that passes through the 2 points 3, 4, 3, 4, and the point 5, -1. Okay, so we have two given lines that pass through two given points, and we want to know if they're parallel, perpendicular, or neither. Well, in order to determine if two lines have any relationship, we need to find their respective slopes. And we know how to do this because we've used our slope formula quite extensively. So how does it work? We're taking the difference in the y values for each line and dividing them by the difference in the x values. So let's go ahead and do that. We have -2. This is going to be slope 1, or m sub 1. We're going to have -2 minus a +2 divided by 1 minus 7. Okay, and we simply, well, this is subtracting. We can add a negative. We can add a negative here. This just makes it easier for me to see that we're going in the negative direction. This is -4 divided by -6. We can cancel the negatives and simplify this into 2/3. And that's our slope for line 1. Now let's find m sub 2, our slope for line 2. We have 4 minus a -1. Let's be careful with our negative signs. I like putting them in parentheses. Divided by the difference in our x-coordinates, 3 minus 5. These two negative signs cancel. We can add a negative here. So this will be 5 in the numerator minus 2 in the denominator, which is a minus 5/2. I always like having the minus sign in the numerator. Just clarifies things for me. So we have slope 1 here and slope 2 here. We can clearly see by comparison that the slopes of our two given lines are not equal, which would make them parallel. And they're actually not negative reciprocals either, which would make them perpendicular. So these two lines are classified as neither parallel nor perpendicular. Okay, for perpendicular, they need to be negative reciprocals. Here, one's positive and one's negative, but they're not reciprocals of one another. So let's look at a few more examples. We're classifying lines here. Let's say line 1 passes through the 2 points 1, -1, and 9, 0. And we have line 2, our second line, passes through the 2 points 2, -10, and 1, -2. Okay, so what do we need to know here? We need to know the slopes of the two lines so we can compare them. So slope 1, or the m sub 1 is the slope of line 1. We can find that by -1 minus 0. We're subtracting our x-coordinates, and we divide that by the difference in our, or subtracting our y-coordinates and divide it by the difference in our x-coordinates. So 1 minus 9. So we have a -1 over a -8. Cancel the negative signs, and we have a 1/8 for m sub 1, the slope of line 1. So let's go ahead and find m sub 2. So we have -10 minus a -2 divided by 2 minus 1. These two negative signs cancel. We can go ahead and make this plus a negative instead of just subtracting. We have a -8 in the top and 1 in the bottom, so we have the slope of -8. I like to leave it in this form, especially when we're trying to figure out if two lines are parallel or perpendicular, because we can actually compare these and notice that m sub 2 is the negative reciprocal of m sub 1. Now we can check this by multiplying these two slopes, and we should get a -1 if they're perpendicular. They're definitely not parallel because they're not equal to each other. They have opposite signs. So let's multiply them together. We have a positive 1 over 8 times a negative 8 over 1. Positive and a negative gives us a negative. 1 times 8 is 8. 8 times 1 is 8. This simplifies to -1, which means that these two lines are indeed perpendicular. Perpendicular. That means that their slopes are negative reciprocals of one another, and when we graph these two lines should intersect, making a perfect 90-degree angle. Okay, let's look at a couple more. Let's say we have line 1 passes through the points 5, -5, and 1, 3. We also have line 2 that passes through the points 0, -2. Sorry about that. 0, -2. And the point 1 and -4. Okay, first thing we want to do is we want to find their slopes. So m sub 1, the slope for line 1, is -5 minus 3 divided by 5 minus 1. Very straightforward. We're just using our slope formula. Okay, so we get a -8 divided by 4, which is a minus. Let's go ahead and leave it in a rational number form, but let's go ahead and actually still write it as a fraction. So instead of writing it as -2, let's go ahead and leave it as -2 over 1, so it would be a little more easier to see if they're parallel, perpendicular, or neither. It's a little simpler to compare rational numbers like that. So slope of line 2, we have -2, that's ugly, minus a -4, minus -4 divided by 0 minus 1. -2, these two negatives cancel, so we have -2 and a +4 gives us a +2 divided by a -1. And if we put our negative in the numerator, we can see that we have a -2 over 1. So both these slopes, the slopes of the two respective lines, both equal -2, or -2 over 1. So this means that these two lines are parallel. Whenever two lines have the same slope, that means the lines are parallel. They will go forever in each direction, and they'll never intersect. So that's always helpful to know. We have time to do one more. Let's say we have the line that passes through the point 6, -1, and let's say it passes through the origin, 0, 0. And then we have line 2 that passes through the point 5, -2, and 7, -14. All right, let's go ahead and find their slopes. M sub 1, the slope of line 1, is -1 minus 0. This one's pretty simple because we're going through the origin. So two of our terms are 0, so we just have a -1 over 6 for the slope of line 1. M sub 2 is -2 minus a -4, or excuse me, a -14 divided by 5 minus 7. All right, these negative signs cancel, and this gives us a +12 in the numerator and a -2 in the denominator. We can simplify this and still leave it in rational form as minus 6 over 1. Okay, now here they're both reciprocals of each other. 1 over 6 is the reciprocal of 6 over 1, but notice that they're both negative. One's not negative, and one's positive, and we can see this by multiplying together. We have -1 over 6 times a -6 over 1, which the negatives will cancel, giving us a +1. Now, in order for the lines to be perpendicular, it must be a -1. And this is not a -1, it's a +1. So while they're reciprocals of one another, they both have the same signs. So these two lines, while they're clearly not equal to each other, so they're neither. They're neither parallel nor perpendicular. Okay, we'll do some more of these in the next video. We're just working on classifying parallel and perpendicular lines as either parallel, perpendicular, or neither, just by using information that we already know. So we'll do some more in the next video. I'll see you soon.